Good morning, everyone. I hope you've had a great weekend. This week, we'll be having our week 3 of our online distance learning sessions. And for this week, we're going to be discussing more about exponential function graphs, pretty much everything about exponential function graphs, from their asymptotes to translations. So hopefully, this might seem to be more abstract than what we've had for the last few weeks, but hopefully you understand it. And if you don't, anyways, there's always our weekly Google Classroom to actually, weekly Google Docs to actually share your thoughts so that we can actually go about it. But before we actually go to our lesson, I would like to remind you of the safety protocols that PGCPS has put up. Okay, here we go. So please be reminded that the PGCPS administrative procedures regarding appropriate use of technology, social media, and email continue to apply to our online instruction. In addition, this session may not be recorded without the instructor's consent. So as what we've been going through the 2 weeks before, instead of interpreting this as being recorded without my consent, it's more like the recording could not be shared without my consent. So please let me know if you would like to share it with your friends because you think it would help them. A description of the applicable procedures is provided online in the Student Rights and Responsibilities Handbook. Thank you for your cooperation. So if you would like to read more on this responsible use of technology, you may, of course, read that in the PGCPS Student Handbook, which is readily available in the PGCPS portal. Also, if you would not like to go actually there, I think you can also access the Student Handbook on a link that I provided in the beginning of the school year. So you may check there as well. All right. Anyways, on to our lesson. So our lesson for today, let me just clear this. Here we go. Aha, there we go, people. Exponential graph transformation. So we're going to talk about reflection and translation for exponential graphs. Okay, so last 2 weeks we were talking about its applications, the general stuff, but now we're going to go more in depth about how the graph varies depending on what you add more to the function. As of course, you don't expect that every model follows the easy version. You expect it to have some certain variations. And this is what the purpose of understanding what happens with extra things put up into the function. So before we go to the main lesson, let's look at the objectives. So the objectives for this week would be to describe the transformation that occurs, whether it's a reflection or a transformation. We will not go over rotation. This is just a bit too difficult for us to handle right now. Next, we are going to identify the graph of an exponential function given transformations. Right, so probably in the work that I'm going to give you a parent graph, and then I'm going to give you the new graph or the new function model for a new graph, and then you are going to predict where that which of the choices would correspond to the transformed graph following the additions to the original exponential function. All right, so review first. Okay, so note that we defined an exponential function to be of the form y is equal to a m raised to the x, where a is our y-intercept and m is the multiplier. Okay, so the multiplier is the number that you keep multiplying so that you actually figure out what the next term is. An exponential function is an exponential growth when m is higher than 1. Okay, so if m is higher than 1, like 1.01, 2, 1 million, definitely you expect the exponential function to be that of an exponential growth function, which means it's increasing as the values of x go higher. While it is considered an exponential decay if the value of m is between 0 and 1, which means it's a proper fraction. The numerator is smaller than the denominator. Okay. Oh, this is not b, but rather it is m. I think I might have slipped my typing there. I did not notice, but definitely when I upload this into our Google Classroom, that will definitely be changed. Right? In this particular context, all right, we're only going to consider m to be positive. A could be negative, but we will keep m to be positive. Right? So let's go over now this transformation, shall we? Right? Aha, so these are the graphs of our exponential functions. The red graph indicates an exponential growth. Notice how the value of y increases as the value of x increase. So as you go further right, the graph goes further up. Okay, this is an exponential growth function. The blue one on the right is actually an exponential decay function. So as it goes further right, notice that the y value actually dips down. But notice that this graph does not cross over the x-axis, which means this graph doesn't have any negative y values. The nature of this graph is that it goes low, all right? As it moves further right, it approaches the x-axis. It gets close to it, but it will never touch it. This is the same manner is observed for exponential growth, but instead of considering the right end, we actually look at the left end. So for exponential growth, if you actually look back at lower x values, notice that its left end is actually getting close to the x-axis, but never touching it. This type of behavior, wherein there is like a line which guides a particular end of a graph, is referred to as an asymptote. In this particular case, for an ordinary exponential growth and exponential decay function, the asymptote is at y is equal to 0. Take note, horizontal lines have expressions y equal to something. Vertical lines, on the other hand, have expressions x is equal to something. The reason for that is that for a horizontal line, the y-coordinates are all the same. In this case, the y-coordinate at this point would be the same as the y-coordinate at that point, and also at this point, all of them being y is equal to 0. That is why the asymptote for an ordinary exponential growth and decay function is y is equal to 0. All right, and here we go, as I mentioned, okay, the asymptote. So if a is higher than 0, an increasing exponential function is expected for an exponential growth, while a decreasing exponential function is expected for an exponential decay. If a is positive, as I mentioned earlier, the only positive we're going to consider for this particular lesson would be m. So a could be positive, it could also be negative. Okay. Now, let's consider the first type of transformation for this lesson, which is reflection across the x-axis. A reflection across the x-axis can be achieved if A is negative. So whether it is an exponential growth or an exponential decay, by making A negative, you automatically reflect the exponential graph across the x-axis. The asymptote is still the same. It doesn't change. It's still y is equal to 0. All right, so the next slide, we're going to look over some particular graphs and see how the reflection worked by switching the A to become negative. So this blue graph is an example of an exponential growth. Notice that A is positive and that the graph is actually increasing. However, by switching A from positive 3 to negative 3, note that the graph is actually reflected across the x-axis. When you say to reflect across the x-axis, think of the x-axis as a mirror. So this is your mirror. So whatever you see above it should be the same below that. That is what you refer to as a reflection. This number here, 3, which is our A, the y-intercept would be found here. This part would be the y-intercept, which you expect to be positive 3. You actually expect a similar y-intercept when it is reflected. But instead of positive, you see it at the negative part. So the A is still determined by this value, but in this case, it is now negative. So that's in this case, A is negative 3, right? Which is, of course, just a reflection of that particular point across the x-axis. The same procedure is seen with exponential decay, as seen on this graph at the right. Asymptotes, all right, y is equal to 0, did not change. The asymptotes are still the same whether there is a reflection on the function. All right, so reflections are not too difficult to look at. You just have to like really turn it over. All y values, all positive y values become negative values. Now, reflection would be the first transformation you consider. So later, as we go to translation, if the function you are given with has reflection and translation, you always consider reflection first. Aha, all right, as I was saying. So in this case, all right, we're now going to look at translation, horizontal and vertical. Translation is the movement of the graph horizontally or vertically. It does not affect its orientation. Thus, this is different from reflection, as reflection changes the orientation. It flips it from increasing to becoming decreasing as it reflects. It's also different from rotation. Rotation, as I mentioned earlier, is not going to be discussed, as the math for that is beyond the coverage of the lesson we are supposed to go over. Okay, so now we're going to complete the standard exponential equation function form. All right, so before we stayed with A times m raised to the x, but this time we're going to put an h and the k. So the h and the k actually controls the vertical and horizontal translation. H controlling the horizontal and translation, while k controls the vertical translation. Right? So the important thing here to remember is that this one should be a minus, right? It should be x minus a particular number for h to be considered positive. if it were written as x plus something, then the h you are considering is actually negative. This is very, very important. So for the h, you need to be very wary of the sign or the operation in between the x and the h. If the operation in between is a minus sign, that means h is positive. If the operation in between is a plus, then h is negative. Following a Cartesian coordinate system, a negative horizontal means movement towards the left, and a positive horizontal, or a positive horizontal translation is a movement towards the right. Same with the vertical ones. A -1 for the vertical translation means it's going to shift down, whereas a positive means it's going to shift up. Okay. So while h follows the opposite sign, k follows the real sign. So if it were plus here, then you consider k to be positive. If it were negative over here, then you would consider k to be negative, which is of course a shift down. All right, so here we go. So here are examples of vertical and horizontal translations. So the blue one, the blue graph, is the original exponential function graph. So in this case, we're only considering translations, but later we'll of course consider translations with reflections. So this blue graph here on the left has the exponential decay function of 100 times 0.1 raised to the x. All right. The blue one, the blue graph on the left, has an exponential growth function of y is equal to 2 times 5 raised to the x. Now, we're going to apply vertical and horizontal translation to them. We're going to apply horizontal translation here to the graph on the left, while vertical translation on the graph to the right. So in this case, to apply a horizontal translation, the exponent x, right, has to be appended with either a plus or a minus operation with a particular number. In this case, we chose -2. Okay. Thus, we now have a new graph here, which is y is equal to 100 times 0.1 raised to the x minus 2. So notice the similarity between the two exponential functions and that slight difference of their exponents. So notice that for this red function, you actually have an h, which is 2. Take note, the operation is minus. So therefore, you understand that h has to be positive. H being positive means a translation horizontally towards the right. Okay, so from this particular function, we will call this a parent function. A parent function is defined as the original function without any translations. So we will refer to this as the parent function. Okay, so notice how the parent function moves 2 units towards the right, following the horizontal translation of -2. Right, to prove that, okay, I looked at the a values. So in this particular case, for the blue one, the a is positive 100, and it is found that x is equal to 0. So if this one moves 2 units to the right, thus you should find the a value here still 100, because it moved neither up nor down, but rather just to the right. So it is the x value here which actually changed to positive 2, emphasizing the 2 units to the right horizontal translation. Okay. Now, if you look at vertical translation here, okay, this is evidenced by having a term after your a times m raised to the x. That is what is different from here. We actually appended a minus 10 after the whole a times m raised to the x term here. Notice it's a minus 10 here. This is the k. So since k follows the real sign here, being a minus operation, that means k is negative, which means the function should actually translate 10 units down, right? So by translating this 10 units down, this also affects your asymptote, as the asymptote is a vertical guide. It stops the function from crossing the x-axis, unless it was, of course, that is correct, even if it was reflected. Okay, now because k is a vertical translation, from the asymptote being y is equal to 0, it shifts down to y is equal to negative 10. Right, so this is one indicator that it indeed has shifted 10 units down. Another indicator that we can look at would be the a value. In the original function, the a value is simply 2. Right, this is our y-intercept, which we conveniently locate here. However, because of the translation, 10 units down, so from 2, we actually have to move this 10 units down. So we can either count 10 units down, or we just simply subtract 10. So 2 minus 10, 2 minus 10 definitely gives us negative 8. Okay, this is how we can show that this function definitely underwent vertical translation from the parent function. All right. So I hope it's quite clear so far. If not, of course, you can rewind through the previous parts or something, because the next slide after this will actually go over to a particular example wherein we talk about both transformations, reflection and translation together. Now remember, as I mentioned earlier, when you are given several transformations, you consider reflection first before translation. Right. So here we are asked to draw the graph of the exponential function y is equal to negative 1000 times 2/5 raised to the x plus 1 plus 100. All right, so notice that this one has all the transformation. The a is negative. Definitely that means something. There is a plus 1 in the exponent. Definitely means something. And there is also a plus 100 after your am raised to the x expression. Right. Okay, so if you would like to determine what this graph looks like, if you would like to predict it without actually using a graphing tool, you may do so. Right? You may pause the video, try to figure out how you're going to graph it. I'll give you a hint. You can draw positive 1000 times 2/5 raised to the x first, and then work the translations and reflections from there. Right? So if you'd like to work it on your own first, you may pause the video, try to do the work on your own, then unpause it when you're ready to check your answers. Okay? I think that should be enough time for you guys to have paused it and unpaused it. Right? We'll now go over to the solution of this particular exponential function. All right, so as I mentioned, the first step would actually to determine the graph of the parent function, which means positive a and no additions to the exponent or to the expression of, or any additions after the expression a times m raised to the x. So the first thing we're going to graph, just to give us a help, on trying to like figure out what the graph would look like is to graph this one first. 1,000 times 2/5 raised to the x. Since a is 1,000, we expect the y-intercept to be at 1,000. Now looking at the m term, notice that the m term is a proper fraction, which means we expect this graph to follow an exponential decay type of behavior. Okay, so if it's exponential decay, we should expect it to go lower as it goes further right. Asymptote is still y is equal to 0. So knowing this point, right, the A, and knowing also the asymptote at y is equal to 0, we can simply draw an exponential decay function. Notice how the asymptote will actually limit the behavior of your graph. So this line here will actually move close to the asymptote, right? But it will never touch it. Now that you have drawn the parent function, it would now be easy to identify how the graph transforms by looking over at the different transformations it has. All right, so let's try to like look at the different transformations it has. So first, it was reflected across the x-axis. This is true because a is negative, all right, as indicated by negative 1,000. So we expect this graph to be reflected over here. So from 1,000, we expect it to be at negative 1,000 now. Okay, below it's still at this line, but over there. And instead of going down, we expect now the graph to actually be going up because it's a reflection. Remember, in the reflection, this is your mirror. So definitely the closer it is, or the closer the point is to the mirror on the positive side, the closer it should also be on the negative side. Next, since the exponent is x plus 1, right? Take note that the operation in between the x and the 1 is positive. So therefore, our h is negative 1. Remember, h follows the opposite sign. If the operation is plus, then h is a negative number. If the operation is a minus, then h is a positive number. Okay. And now h, being a horizontal translation, all right, and being negative, it means to just move towards the left. So if h is negative 1, this tells us that the graph actually moves 1 unit left. All right. So first, it reflects. Okay. So we expected the A. We expected the A to actually be at negative 1,000, but it also moves 1 unit towards the left. So instead of being at 0 and negative 1,000, the A here would move to negative 1 and 1,000, which is logical. Everything else also moves. All right. So yeah, that's pretty much okay still. All right. Finally, we have the vertical translation. Notice that there is also a plus 100 at the end of the expression a times m raised to the x, which is a vertical translation. Now, being positive, it means that the translation vertically has to be upward. Okay, as a positive vertical translation is up and a negative is going down. So after it moves 1 unit left, we now actually have to move everything 100 units up. Now, take note that vertical translations affect the behavior of your asymptotes. So your asymptote from y is equal to 0 would also move 100 units up. All right? So from y is equal to 0, your new y asymptote would be y is equal to 100. All right? Now similarly, this A point. First, it was moved here, and it was 0, negative 1,000 because of the reflection. Then it became negative 1 and 1,000 because of the horizontal translation. And then finally, it has to move 100 units up. So from negative 1, negative 1,000, the y value, the negative 1,000, has to be increased by 100. So negative 1,000 plus 100 gives us negative 900. So you expect this point now to have traveled to negative 1, negative 900. All right. Let's look at the particular values. All right. So this was the first transformation, the reflection. So it starts off the A being at 0, 1,000. It reflects to 0, negative 1,000. The horizontal translation, because of this part, it moves 1 unit towards the left. Right? And then finally, right, everything moves 100 units up. So from negative 1 to negative 1,000, it actually moves now to negative 1, negative 900. So is the behavior of the asymptote. It is now at y is equal to 100. All right. So pretty much this will be our lesson for the week. I will definitely upload this on a Monday so that for those of you who would like to review it much sooner, you'll definitely will be able to. And you can just post in questions on Tuesday when I actually am going to be online. All right. So I hope you guys keep staying safe. All right. I hope that you guys study well. I know that being stuck at home might be frustrating, but it's definitely keeping us all safe. So I'm looking forward to seeing you guys very soon. If not this school year, maybe next school year when we begin that year, right? So I hope you've learned something today. All right. Again, keep safe. This is Mr. Trocino saying bye-bye.